Our next parent function is the cubed root function. So the cubed root is the inverse of the cubic root. So when we do the cubed root, we want perfect cubes for our x values. So these we want to be perfect. So we're actually going to flip the table of the cubic. So I'm going to put in here, so perfect cubes would be -8, -1, 0, 1, and 8. All right, so if you recall the table above it, these y values are now our x values. They're perfect cubes. So when I take the cube root of -8, I get -2. Cube root of -1 is -1, 0, 0, 1, 1, and then the cubed root of 8 is 2. All right? So when I graph these, so you still get the same curve, but now instead of pointing up and down, it's pointing left and right. So instead of being more vertical, it's more horizontal. So we can say this one's the sideways S, whatever you want to remember it. Sideways S shape. All right, so the 0 is where it crosses the x-axis, so the x-intercept is still 0, 0. Y-intercept is still 0, 0, where it crosses the y, so again, everything's centered in the origin. All right, increasing interval, so remember this is where we're looking on the x-axis from -infinity to infinity, and I'm tracing this graph left to right. So notice the whole time that I'm tracing, my pen is going upward. It's increasing the whole entire time. So that means the whole entire thing from -infinity to infinity is increasing. Domain is what x values does it hit. So remember we look for arrows on the left and right. Since it has arrows on both sides, we can say all real numbers, or you can do -infinity to +infinity. Range is what y values, so we look up and down. And you can see that we have an arrow going upward. On this side, it's going up. And then this arrow is going downward. So we do have an arrow going up and down. So our range is all real numbers, or -infinity to +infinity. All right, positive and negative, this is where we highlight above the x-axis, below the x-axis. So if I'm looking at this piece here is above, and then this piece down here is below. Notice again that the point 0, 0 right there in the center is neither positive nor negative because its y value is 0, and 0 is not a positive or negative number. All right, so we have the green piece, which is our negative, between these two x values, -infinity and 0. And then we have this yellow piece, which is the positive one, in between these two x values, so 0 to infinity. Again, parentheses, because you're not including 0 or the infinity as part of the positive piece. All right, two more parent functions to talk about. The next one is our exponential. So notice it has this c here, and x is actually an exponent. So notice the word exponent in exponential. That means you can have any number you want for c. So c is a constant. So c is going to equal a number. So there's many parent functions for exponential. We're going to do 2 to the x. So this means that I can plug any x value that I want and it becomes an exponent. So I'm going to pick my favorite, 5. All right, so if -2 is our exponent, let's think about this. if you remember, when you have a negative exponent, you actually take the reciprocal of this base. So instead of saying 2 to the negative 2, the reciprocal would be 1 over 2 squared. So the negative exponent now becomes positive, which is 1/4. Right? So 2 to the negative 1 would be 1/2. 2 to the 0, so anything to the 0 power is the number 1. 2 to the first is 2, and 2 squared is 4. So if you look at the 2, you get 4, and then negative 2, you get its reciprocal, 1/4. 1, you get 2, negative 1, you get its reciprocal, 1/2. All right, so when I graph these, all right, it's going to level out right along the x-axis. The reason it's never going to touch the x-axis is there's never an exponent that you can put right here that's ever going to give you 0 for an answer. Because if I use negatives, I get the reciprocal of the positive. And when I use 0, I get 1. So we have our first asymptote. So I'm going to put this in here with a different color line. So a lot of times when you see asymptotes, you're going to see them as dashed lines. All right, so we have this horizontal asymptote that this graph is leveling out at. All right, so whatever you want to call it for the shape, I'll just write curve again. I know we used curve already, so that's just your preference. Horizontal asymptote. So remember horizontal, we use the word shortcut to help us remember HOI. Horizontal, slope is 0. The equation of the line is y equals to a number. So y equals, and the y value here is 0. So y equals 0. All right, y-intercept, it crosses at the point 0, 1. Increasing, we trace. So if I start on the left and I trace, I'm going upward the whole entire time. So the whole entire thing is increasing from negative infinity all the way to infinity. All right, domain, remember we want to look for arrows on the left and right, and I do. I have an arrow going to the left towards negative infinity, and I have an arrow on the right going towards positive infinity. So all real numbers, and then negative infinity to positive infinity. All right, range is what y values does it hit. Well, we look for arrows pointing up and down. Well, I do have an arrow pointing up, and I do have an arrow pointing down, but this does not point down forever because we said it's leveling out along this blue horizontal asymptote. So it's never going to hit 0 or any number below it. So when I write this out, I could use 0 in parentheses to infinity. So everything from 0 above 0. Or if you want to use set notation, all values of y such that y is just greater than 0. Remember, we can't hit 0. All right, and then positive notation. Remember, positive is above the x-axis. So if you look, the whole entire graph is above the x-axis. So all of this is above it. So notice there's no point even on the x-axis that touches it. So that means the whole entire thing, negative infinity all the way to infinity, is above the x-axis. All right. Last graph is our rational graph, rational function, sometimes called the inverse function. All right, so we can pick any x value we want. So I'm going to go ahead and pick these x values. So if I plug in a -2 for x, I get 1 over -2, which is -1/2. 1 over -1. All right, 1 over 0. Remember way back in elementary school, this is a no-no. So you can never have 0 in the denominator, so it's undefined. There's no point there. 1 over 1, and then 1 over 2, so 1/2. All right, so when you plot these, it's going to be a little bit different than what we just had. All right, so this reciprocal or rational function actually has two pieces. All right, so we have curves in quadrant 1 and 3. All right, and it actually has two asymptotes. So again, it's leveling out without touching the x-axis. So we have an asymptote here. All right, and that's at y equal to 0. But then we have an asymptote that runs here vertically. So remember with vertical, we use the word vux, V-U-X. So this means x equals, so x equals 0. Remember horizontal, the shortcut is to remember the word hoy. Horizontal is y equals, that's why it's y equals 0. All right, if I trace left to right, all right, let's look at this for a second. So here's the most left point. If I trace it, notice that I'm going downward. So this is decreasing. If I trace this piece on the left to the right, the same thing, I'm going downward. So everything is decreasing. So remember this 0, we use the x-axis. It doesn't exist on the graph. So we have to do it in two pieces. So I want to go from -infinity to 0, and then from 0 to infinity. All right, so -infinity to 0, union 0 to infinity. All right, domain. So again, we said x values are going to go from -infinity to 0. Remember, we're not touching 0. And then 0 to infinity. So same idea. So if you're using set notation, you can say all values of x such that x doesn't equal 0. Or you can write it in interval notation just like we did the decreasing interval. Right? From -infinity to 0 and 0 to infinity. All right, range is up and down, y values. I got an arrow pointing up, arrow pointing down, but notice it skips this blue line where y is 0. So same idea that we did for domain, but this time you do it with y's. All values of y such that y does not equal 0. Or you can use this exact interval notation right here. All right, positive and negative. So positive is above the x-axis, so if I highlight above, that would be this piece over here. Oops, that went way out of control. So this piece here is above. And then if I have below the x-axis, it would be this piece here. Oh gosh, not very straight. All right, so let's do above the x-axis. Let's do the positive one first. So if I look at the yellow, so it's here at 0 to infinity. And then if I look at the green, all right, which is right here, if I look on the x-axis, it's between -infinity and 0. All right, so those are your parent functions.